Hey, what's up, guys? So we had a really tremendous rally today. I think the S&P 500 was up maybe 9% or so. Large rally. And so, I was reading through Bloomberg and I came across this really interesting article, and it was basically asking the question if this was just a short covering rally. And so I looked at this, and hopefully you can see this here. It was JP Morgan predicted a short covering surge, and it has arrived. So I think the premise of the article was that many of the companies that rallied today had weak balance sheets. It was the high debt balance sheets that really rallied today, and so what would that imply? It would imply that maybe the shorts they've covered. They've just basically covered, and that was really the push of the rally. So I wanted to test that hypothesis or that theory. So to do that, I just pulled some data. Again, if you looked at my last video, I've been pulling my data from FinViz, and you can create a little premium account to pull some of this data and export it. So I've exported it to Excel, so you can pull that data, check this out. And so what I've done is I've imported pandas, NumPy. I read that CSV file that was exported from FinViz and put it into a data frame. And so I wanted to test that hypothesis. So let's state our null and alternative hypothesis here. So our null hypothesis, that's what we're not really interested in. That's what we want to test for, is a low quality balance sheet company 1-day returns equal high quality company balance sheet returns. And our alternative hypothesis, what we're really interested in, that's low quality balance sheet company 1-day returns do not equal high quality balance sheet company 1-day returns. And so that's what's more interesting here, and we really want to test that and see, is it true that bad balance sheets the 1-day return for this rally did not equal good balance sheet 1-day returns. So once we've done that, we stated our null and alternative. We have to state our test statistic and probability distribution. Since we're comparing two sample means, this is the test statistic that we're going to be using. I'm assuming a normal distribution for both populations. I'm also assuming that the variance for the populations are going to be equal. And so let's go through this. And if you have more questions about the math, I've done some other videos on the math specifically, but I'm not going to exactly do that in this video. So this is how I specified my sample population. So I looked at, for a bad balance sheet, I said that the total debt to equity ratio is greater than 1. And again, I'm getting this all from this CSV file where I have this data frame, and you can see all the different columns in here. So we have ticker, company, sector. We're going to look at this total debt to equity column here, and we're also going to look at the current ratio column. And if you remember, current ratio, that is just your current assets divided by your current liabilities, and it's really just showing how well a company can pay its obligations, its short-term obligations. So again, back here, how we're going to specify these populations, sample sets, we're going to say that total debt to equity for a bad balance sheet will be greater than 1. The current ratio will be less than equal to 1, because remember, the smaller that ratio, basically saying that the denominator, the current liabilities, are larger than the current assets. So it's harder for them to pay those short-term obligations. Finally, we're going to remove the financial sector, because that's usually, we don't want to skew the data. Financials usually have higher debt in general. And then I've also added this other interesting variable here, and that's called relative volume. And relative volume, that's basically looking at the current volume of the day divided by the average 3-month volume for the security in question. And so basically what I'm trying to measure here, look at here, is the biggest movers given the average volume. So where was the most volume of trading for security? And so, because again, we're trying to understand what really ran or pushed this short covering rally, quote unquote. So we're looking at our bad balance sheet will be total debt to equity greater than 1, current ratio less than equal to 1, and then relative volume is equal to greater than 1.5. And for our good balance sheet, we're going to say that our total debt to equity ratio is less than 1, and the current ratio is greater than 1. And finally, again, these two assumptions are going to be the same, excluding financials, and relative volume greater than 1.5. So given that, we have a sample size of 130 for the bad balance sheet and a sample size of 585 for the good balance sheet companies. So now we have done that. We can create a degrees of freedom of 713. Again, if you're interested in math, check out some of my other videos. We're going to specify a decision rule. So our rejection point is going to be negative 1.96 and positive 1.96. Now we can actually collect the data. So again, I've stated this before. We want to state a hypothesis first before we do any data mining. So we've done that first. Now we can actually collect and calculate our test statistic. So in this data set, there's a column called change. I just need this is some cleaning up that we're doing. It's actually in a string format. I'm just going to convert it, take off the percentage sign and convert it into a decimal. And so that's what I do here. And now prior to this was 6.27% in a string, and now I just converted it into a float or a decimal. So we can work with this data set. All right, so again, I've created my sample population, bad balance sheet, DF. I've called that this data frame here, and our good balance sheet data frame here. So let's start calculating this out. So we can actually create histograms. So here I've done a histogram of a bad balance sheet and a histogram of our good balance sheet. And so not entirely intuitive here. We can see it looks to be somewhat normally distributed. The variance may be different, but we'll see and check for that. Now let's calculate our means. So again, the bad balance sheet percentage change for the 1 day change, and then we're just talking about from yesterday to today. Looks like the mean was about 13%, and for the good balance sheet, 9.9%. So we need to test that. It looks like there's a difference though, so that's interesting. Then we can get our variance for both of these sample sizes, sample populations, and it looks like they're fairly close. And now we can just use our stats library. And so you could take all these variables and plug it into this equation here. But an easy way to do it is just you can use from SciPy import stats, and we can just plug in the different arguments here. So we have our bad balance sheet change, our good balance sheet change column. We assume that equal variance is true, and we exclude any not a number variables in here. We omit them. And so what we get is we get a p-value of less than 0.05 and a strong test statistic of 2.78, which 2.78 is larger than our rejection point or decision rule of 1.96. So what does that imply? How can we interpret that? Well, we can reject our null, and that is low quality balance sheet company 1 day returns equal high quality balance sheet company 1 day returns, and accept our alternative hypothesis that low quality balance sheet company 1 day returns do not equal high quality balance sheet company 1 day returns. And so what does that mean? There seems to be a definite difference, or at least from this data, it shows that the low quality or bad company returns did outperform the good quality companies. So that may imply that this really was a short covering rally. It may imply that is the case, that shorts really did just cover on these really bad companies, and that may have been the reason for the rally. So we'll see what happens tomorrow or the rest of the week. If you like this video, please subscribe. Till next time, guys. Thanks.